Okay, so what are your goals and what do you hope to get out of these sessions?
So my goal, I want to be able to transition into more of a tech side. I got a strong background in tech. Uh, Come from a different field entirely. I want to transition in, and I just feel like I don't have that understanding of where to get that from the first level to eventually become like a full-time
Okay,
coder or somewhere in tech. So my goal is essentially is to get the foundation, build off of it, and create a portfolio strong enough to be valued and a strength of mine.
okay. And what's your current experience with programming and computer science?
Zero experience coming in from a completely different background. Um, and yeah, I sincerely was just questionable about all boot camps and everything else that kind of come in between. So yeah, I'm
Okay,
just a guppy.
okay. All right, so to answer your question just now about what platforms we're using and what platforms we'll be learning, I tend to start absolute beginners in a programming language called Pirate because you can just program on the web browser. It's very easy. You don't have to download anything. And it will transition you into Python, which is a very common industrial programming language. Okay.
Fantastic.
Yeah. And as for like transitioning into like software as like a career, it takes time and commitment. Like these sessions, like they're 1 hour per week. They're not going to be enough. You're going to need to spend time outside of these sessions practicing, acquiring new skills. So if you're really looking to transition into software as a career, I would definitely treat these sessions as more of a supplement rather as the main thing that's progressing you, you know? So my goal for you in this first session is just to get you started in programming, get you comfortable enough where you can start experimenting, start doing stuff on your own. And yeah, we'll take it from there.
Let's do it.
Okay.
And if there's, of course, any recommendations to really kind of get a main source or whatnot, I mean, that would be fantastic. So I'd really appreciate it.
I am basing all my sessions on two textbooks, which I believe are very good. I have that in my rated post if you saw that, and I can also send them to you again at the end of our session.
Sure thing.
Good. Give me 1 second. I'm going to send you a link. All right, I just sent a link in the Zoom chat. If you could open that and share your screen with me, that'd be great.
Okay, no problem. Let's see. I'm sorry, it's been a while since I've used Zoom. Uh,
That's okay.
so sharing screen. Mhm.
Very nice. Okay. To start with, I would like you to think of two big numbers and add them.
Okay, and the four digits, five digits, six digits, or just
Big enough that you can't calculate it in your head, but small enough where you can write it quickly.
okay, let's do add them. So just right, put a plus on, yeah.
Cool. Okay. So at the top right of your screen, there's a run button. Let's click on that. Okay, congratulations. It's your first program.
There we go.
Okay, yeah, the math is right. Okay, so using like programming is like using a calculator, which is not surprising because a calculator is a computer, right?
Hmm.
Okay, let's add a third number in there and see what happens.
On the same line.
Yeah.
Mm, um,
Nice. Okay, so you can add three numbers. Could we change one of the plus signs to a minus?
let's see, why not?
Oh, what happened here?
Parenthesis, like, okay, PEMDAS. Okay, okay, so would look like something like that. No, you may need to add or remove some text to fix your program.
So it doesn't understand the comma. So let's remove the comma and let's run that again, just to get the first error message. So
Okay.
you have the right idea. So you say pandas, right? The idea of order of operations.
Hmm.
So what it's saying is that it doesn't know whether or not to add or subtract first, and it wants you to add parentheses to determine which one should be done first.
Right.
Yeah. So we shouldn't be using a comma, we should be using a parentheses. But how do we use parentheses here?
I would assume whenever using a negative number, kind of like in finance, instead of using negative sign, we'll use parentheses to open and close.
Yeah, could you show me?
Let's try, like indicating a negative, I guess, outcome. Negative sign, parentheses. Here we go. Okay, now, okay.
Well, we'll need a minus sign, right, to say subtract.
Yeah, okay, I was just, yeah, just practice.
Okay, let me ask you,
Plus
do we want to add first or do we want to subtract first?
I mean, if we're going by the order of operations, then subtract first.
Want to subtract first. Okay. So where do we have to put our parentheses such that it's very clear to a human that we are subtracting first?
Uh, in the beginning.
Can you show me where?
Yeah. So,
Hmm. Okay. So you're thinking that order of operation goes from left to right, right? That's actually
mhm.
not the case. Okay, so I'll tell you what to do. So we want to subtract first, right? Could you highlight to me what the two things are being subtracted?
Well, in this instance, 27,500 and 72,300.
Okay, can you highlight those
Oh,
terms? Okay, so that's where the parentheses should be surrounding.
got you.
Yeah.
Makes sense.
Okay, now let's run it. You
Uh,
don't actually have to put the plus 4800 in a new line. It could actually be on the same line.
oh, I thought, okay, I thought it was on its own. Okay, got you.
Yeah. So it's like normal mathematics. Um, yeah, let's try running this.
Yeah.
Okay. Yeah, we should get the same thing here. Okay, cool. So you said pandas just now, right? And what
Parentheses.
is pandas? Pandas is like conventions in the mathematics we do in real life as to the order of operations when they are not specified. Okay?
Right.
That does not exist here, in this programming language at least. So in some programming languages, there is a thing like pandas, but here's the thing. In programming languages, there are many, many more symbols. There are more than six symbols. There are more than six letters to work with. So the pandas is really like 20 letters long. There are like 20 rules to memorize, which is incredibly painful. But this language is designed for beginners and they don't want you to feel pain. And so they just don't have conventions. You don't have to memorize anything, but this means that you have to be more specific. Let's say you want to subtract first. You want to surround the two numbers in parentheses to say we want to subtract first. Okay.
Hmm.
All right. Could we try multiplying this whole thing by a number?
Yeah, why not? Large number, small, okay, I guess it doesn't really matter
Oh
now.
yeah, any number in this case.
That's just quantifiable. Just say, oh, 20. To just slip my finger.
Oh, you'll need the multiplication symbol, which is asterisk. That's Shift 8 on your
Gotcha.
keyboard.
Yeah,
Yeah. Notice how the parentheses, the outmost one, still contains two operations.
hmm
Yeah. Cool. Okay. Very nice. So what's happening here is first we are subtracting, then we multiply, and then we add. You see that?
correct.
So it's this idea here that the computer can only execute one thing at a time. Now that line is loaded with things, but it's actually doing things one at a time. And what's the order? That's the order as specified by the parentheses. Subtract, times, and then add. Okay. So far we've been using this like a calculator, and we've been exploring the laws of arithmetic, which is essentially the same but minus the conventions. We do not have to memorize any rules. Okay. All right, let's try something a little bit different. And I need you to humor me for a second. Could you delete everything on the left-hand side? I want you to write two numbers separated by a comma. And now surround this whole thing parentheses. And before the first parentheses, I'd like you to write a few letters. NUM dash MIN. So before we run this, what do you think is going to happen?
I would like to think it'll give us the minimum number between the two.
Okay, let's run it and let's see what happens. Okay, that looks right. Let's confirm our hypothesis. Could we make the first number smaller?
Yeah, let's. Oh, sorry. First number smaller. Yeah,
Nice. Yeah. So yeah, it is getting the minimum. All right. So what's interesting about this is that it's still performing an operation, but we're using words here. Yeah.
mm,
And if you think about it, in mathematics, there could be an infinite number of math operations. We can subtract, we can add, times, multiply, and all that. And there could be many, many more. And this is one of them. But there are only so many symbols that we have on our keyboard to use. So, what we have to start using words, which is a combination of symbols if you think about it, right? So this is what it looks like when you use words to make an operate to perform an operation. You use the word, and then you have sort of what it's operating on, the numbers in parentheses. Okay.
Got you.
All right. Let's add this whole thing. So don't delete anything. Just add this whole thing to another number.
Add it to another number.
Yeah.
So like add a on a new line, same line, just do just addition.
Yeah. Yeah. Same line. Oh, yeah, let's run it. Very nice. So the same way we can subtract and add on the same line, we can perform the minimum operation and then add on the same line as well. Okay. Notice how there's no ambiguity as to which operation should happen first. The minimum has like the num min has like parentheses on it, right? So it's
Hmm.
clear as like, okay, that those two, the 2500 and 5600 belongs to num min, and that happens first. Once that happens, we add in 1,000 to it. All right.
Right.
Okay. Can we try something? Can we move the plus 8,000 inside, let's say 2500? So we take the plus 8,000 and move it to 2500 plus 8,000.
Got it. We'll expect just the minimum. Yeah.
Hmm. So what's interesting here is the add is happening first. Yeah.
Hmm.
This comes back now to the order of operations. Well, in order to find the minimum of two numbers, we need to know what the numbers are. To find out what the number is, we have to add it first. Yeah. Okay.
Absolutely.
So the word operations and like the symbolic operations, the plus and num min, they can mix and match. Just one is just uses a symbol and the other is a word. Okay. Okay, so far we've been exploring the laws of arithmetic and we have come across words. Let's do something a little bit different now. We're gonna move forward in time a little bit, and we're gonna talk about a little bit of algebra. So let's delete everything. And I would like you to write x equals 1, and on a new line, x. Now, before we run this, what do you think is gonna happen?
1 equals x.
1 equals x. Like we will see 1 equals x.
Or like 1x rather.
Okay, let's run it and see.
I just want to go.
Just 1. Why do we get 1?
Because 1 equals x.
Okay. So there's a
Yeah,
notion of variable substitution, right?
exactly.
So we say x is 1, so when we see x, we see 1.
Exactly.
So could we change line 3, the x to x plus 1?
Yep.
Okay, let's run it. Let's just see what happens. 2. Okay. So notice how the variables and numbers can mix and match. We can add a number to a variable. Okay. Well,
Hmm.
what's actually happening is when he sees like x plus 1, it's like, oh, what is x? Oh, it's 1. So it's 1 plus 1. It's 2. So really we're adding two numbers, but we're using x as a name for 1. Okay. Yeah. Okay. Um, let's try something. On line at the end of line 2, could you hit enter? So we're creating a new empty line between those two lines there. Could you write x equals 2? Now, before we run this, what do you think is going to happen?
Equals 2. The result's probably x equals we'll probably run it to find x is 3. or a combination. X is now 3 plus 1.
Okay, let's run it and see. Oh, what's it saying?
Oh, yeah, it's a conflict. Yeah, it's not added as a conflict because they're the same.
Hmm. Okay. So, okay, not all programming languages have this. Different programming languages will have different answers. Some programming languages, like Python, will give you three here. But in our case, this programming language doesn't allow it. Some intuition as to why not. If you think about it, let's say we're mathematicians. We say let x be 1, let x be 2, x plus 1. Well, if we say let x be 1, why are we saying let x be 2, right?
Right.
It's kind of redundant. So surely, like, someone must have made a mistake, right? Another way of thinking about this is the term declaration is used. So, like, we declare something. It's like the Declaration of Independence. Once you declare it, you declare it. You can redeclare it, right?
Mm-hmm.
Okay.
Exactly.
Okay. So this is the idea of variable substitution. Could we change the x equals 2 into y equals 2?
Y equals 2. Yeah,
Yeah. And let's change x plus 1 to x plus y.
gotcha. This instance now is 3.
Great. Yeah, 3. And so we can have more than one variables. And we can do something funny as well. We can change line 3 into y equals x.
Line 3 to Y equals X.
Yes. Let's run this and see what happens. Get 2. Now, so we can assign variables to variables. What's actually happening is on line 3, when he sees y equals x, it's going to be, oh, what's x? X is 1. Okay, so y is also 1. So y gets the value 1.
Mm-hmm.
Okay? All right, so this is variable substitution. So we have covered a pretty important idea in algebra. And we're now going to cover another important idea in algebra, which is functions. Let me ask you, what is a function?
In what aspect? What is a function?
Like, how would you define a function? What does it mean for something to be a function?
Um, well, a function is going to be essentially a like an operation. I know a word with
Operation.
yeah, like it would be an operation to basically a rule
Okay,
that will yeah, they'll take a rule based off of input that will generate one output.
nice. Great. Yeah, that's exactly it. A function goes from inputs to outputs. Okay. Okay, so we're going to define a function in this language, and it's going to look a bit funny. It will be pretty different from other programming languages, so you gotta humor me for a second. Let's delete everything on the left-hand side, and let's write fun,
FUN.
yep, space, f, you write a letter f, opening parentheses, x, closing parentheses, colon. If you write a colon, that's the, yep, new line, x plus 1, new line, end. Okay. Yeah, notice how it highlighted there for a second. So that is a function definition. We have just defined a function. Can we click run here? There is a minor problem. Great. Okay, so we've just defined a function. Notice how nothing has happened because we didn't give it anything, right? So it doesn't give us back anything as well. Okay, so a function has three parts. First, a function has a name. So this function's name is f. We've called it f. Second, a function has inputs. In programming, we call them parameters. So here the input of this function is x. It takes in a thing and calls it x. All right? So we call this parameter x. The third thing of a function is its body. So this is line 3, x plus 1. A function has to produce an output, right? How does it produce an output? It performs the operations inside the body to produce one answer and spits that out as an output. So again, there are three parts: the name, parameters, which are the inputs, and then the body, which produces the output. Name, input, output. Name, parameters, body. Okay? Um, Notice how the fun is bolded. That's short for our function. We're telling the programming language we are defining a function. And the last line, end, that's telling the function that's the end of the body. That's how the function knows it shouldn't read anymore for the function definition. Okay, so now let's use this function to do stuff. Can you create a new line? And to use a function, first, we must refer to it by its name. So this function is called f. Let's write f. Next, opening parentheses. Now we need to pass in the inputs. So let's just write any number here. Perfect. And then closing parentheses. Okay, let's run it and see what happens. Ah, we get 4. Okay. So in mathematical speak, we say we are applying a function. But in programming, we say we are calling a function. We are calling the function f with the number 3. Okay. One last idea I want to introduce here is notice how there are two windows. There's the window on the left, which we have been writing in, and the window on the right, which have been giving us answers. I want you to stay on the window on the right. Notice how you could type stuff in. Could you write F opening parentheses and a different number? But the window on the right. Yeah, so F opening parentheses and any number. Okay, and closing parentheses, and now hit enter. We get 8. You see that? So, unlike just now, um, we have answers on the right-hand side, and we are able to write stuff in the right-hand side. So let me explain what's happening here. We have definition. We call the left-hand side the definitions. This is where we define our program. On the right-hand side, you may hear the word console or command line. Uh, the name is actually a REPL. That's REPL. You're able to write one-line programs, hit enter, and immediately get the result. So let's write like, I don't know, like 1 plus 1 here, just to show you. And yeah, you can hit enter. So clicking run actually refreshes the whole thing. You have to hit enter for the right-hand side to work. Oh, by the way, you're muted, by the way. I don't know if you're saying something.
My apologies.
Oh,
Okay.
it's okay. I don't know if you've been
So,
saying stuff this whole time, like the past 5 minutes.
oh yeah, I didn't know. Geez.
Okay,
Okay.
that you got like really quiet. I was like, oh, this guy's very focused.
Yeah,
Okay.
so F7. Uh,
So yeah, when you
minus.
type stuff in the right-hand side, you cannot click run because that will just
Oh,
refresh the right-hand side.
okay. And then we know we did 1 plus 1.
Yeah.
Okay, the white space. Right.
Notice how once you write something, you cannot edit it. It's carved in stone. So yeah, you have to write a new line here. So 1 plus 1 is 2. And we can go crazy. We can do like f of a number and then add that function call to another function call. So can we add two function calls here?
Uh, would it would the number sort of collude? I don't know. They'll be conflicting. You try.
Let's see. That's right.
Guess so.
Ah, we get an answer. Remember how we did plus and num min just now?
Yes.
Well, num min is a function, just like f. We can
Right.
mix and match function. So the term here to use is function calls. We can mix and match like math operators like plus with function calls.
And that's the difference. That's the difference. Got you.
Yeah. Okay. So I said this is the REPL. The right-hand side is called the REPL. It's 4 letters. It stands for read, R for read, E for evaluate. Evaluate means to simplify. Simplify until we can't simplify it anymore. Another explanation for evaluate is to make into a value. That's why there's the word value in evaluate. A value is that which cannot be simplified any further. So 20 is a value. 1 plus 1 is not a value. 1 is a value, however. So that's E. E for evaluate. P is print. So it reads your whatever you write, evaluates it, gets an answer, prints it. So we see 20, right? Prints the answer. And L is for loop, as in it lets you repeat this again and again and again. So this is very good for getting very fast feedback. And this language is designed for beginners, so fast feedback is important. That's why this feature is here. Not all languages have this. Okay.
Right.
Okay, so to summarize what has happened so far, we have covered arithmetic and algebra, all with this programming language. So it seems like we have a pretty advanced calculator at our hands here.
Yeah.
Okay. Now we're gonna shift gears a little bit, but before we do that, I'm gonna need to refresh this Zoom session because it's gonna kick this out. So I'm gonna send you a new link and close this one. So check your Gmail, okay? I'll send you a new link there.
Thank you.
Okay, I'll see you in a minute.
Yeah.
Nice. Okay. All right, so we're gonna shift gears a little bit. Let's delete everything.
Everything on the left or
Yeah.
everything? Actually, yeah, the right is not like that.
All
Got
right,
you.
so let's write the number 5. Okay, and let's run this. Okay, so we wrote 5 and we get back 5. Nothing surprising there.
Hmm.
Okay, so let me ask you, what does 5 mean?
Well, what does 5 mean?
Yeah, what does 5 mean?
Um, I know it's a number,
Okay. It's a bit of a
um,
trick question. Doesn't mean much, right? 5 is 5,
but in
right?
terms of coding, I'm not familiar.
No, no, there's no
Programming, not
special
one.
answer here. It really doesn't mean much. It's just 5. Let me change the question a little bit. What if I say 5 degree
Yeah,
Fahrenheit?
5. Yeah,
Yeah. So when I say 5 degree Fahrenheit, what does that mean?
that degree variant, that'd be it. Sure.
Temperature, right? How hot, how cold something is. How about
Well, that
five
would be
kilograms?
sorry, yeah. No, that would be weight.
Weight, how heavy, how light something is. But they're all 5,
Weight.
right?
Yeah.
So there are two worlds.
Hmm.
There is the world of information. This is ideas and facts about the real world. And there's the world of data. Like that number five in front of us, that's data. That's what the computer sees. It does not know its temperature or kilograms. It's just five. Doesn't mean anything. Okay. Now, this sounds philosophical, but it's a very practical idea.
Right.
Because I claim that our job as programmers is to facilitate the interaction between the world of information and the world of data. We turn information into data, and we turn data back into information. We say we encode information as data. Another way of saying this might be we represent information as certain data representations. Okay. Um, and to reframe everything that we have done so
Mm-hmm.
far, we have been encoding information as numbers and we have been operating on numbers. All right. Now, let me ask you this. Can we encode all information as numbers?
I suppose.
Why do you say that?
So long as under function, I guess you're protected.
What do you mean by that? Can you give an example?
Like how we did like F7, or F3. Um, I like to think if we were using numbers here, we dictate what we want to do with it.
Okay, sure. But how about other kinds of information? For example, let's say like my name, Marvin. How do we encode that as numbers?
It's a little different. Probably not.
You wouldn't use numbers for that?
Um, on first thought, no. But if we're able to manipulate that, perhaps.
Do you know the saying that computers are just a bunch of zeros and ones?
Hmm.
Aren't zeros and ones just numbers?
Yeah,
So we can encode everything as numbers, right?
yeah.
Now, here's the next question. Do we want to?
I bet not necessarily. If we want to, not necessarily, but we can.
We can, not necessarily. What do you say, not necessarily?
Um, might not necessarily be a requirement.
What's an example of that?
Um, coding purely by numbers, it would be, well, I guess if each number was translated to or was converted to a letter, but it might be too complicated to
Hmm,
conduct.
complicated. So it's like complexity, right? If we just write code in zeros and ones, that'll be incredibly painful, right?
Yeah, I feel like the
Okay.
process would be much more strenuous.
Yeah. And like you and I, we are talking right now, but we're not talking in numbers. We're not talking in Morse code, right? We're using words.
Right, exactly.
So we're choosing to transmit information by means other than numbers. So numbers, we don't use numbers for everything after all, right?
Right,
Okay. So what this means is that we want to encode information as things other than numbers, right? And I'll show you just that. Could you delete that five? I want you to write double quotes. And inside the string, inside the quotes, I would like you to write hello, comma, space, world. Hmm. Let's run this. Let's see what happens. Ah, we got back something that isn't a number. It's a whole different animal. We got back a string. It's like a string of characters. Okay? And
Correct.
this is kind of special. It's not a number and it's containing information that numbers cannot describe. Hello world. Now this example, Hello World, it's very famous. It was first written in some book in the 1970s on teaching people how to program. And ever since that day, every book, every video, lecture, tutorial in the universe uses this example, Hello World. It's sort of like a rite of passage. Like a
Hmm.
beginner would always have to write this. So congratulations, you have just reached a very important milestone in your life. Okay, so we call this a data type. Like a number is a data type, a string is a data type. A data type is a classification of data. So here we introduce a new data type called string. Uh, so just now we had numbers and we were able to perform arithmetic on numbers. Could we perform arithmetic on strings? Can we add this string to another string? Can we try that?
Good, we can.
Okay, let's try it.
You said add this string to another.
Yeah.
Okay. So we're just basically adding more, or
No, no, like plus sign. Like literally add, like mathematically add. Yeah. And another string.
gotcha. Um,
Very good. Let's run it. Oh,
okay, okay, white space. So white space. Right. Okay.
nice. So you can add strings together. It just joins them together. Very nice. Hmm. Could we replace the plus with a minus? What would that do?
Let's give it a shot.
Yeah, doesn't like that.
Doesn't seem to be a fan, no.
Hmm. So when he sees the minus, the minus operator expects to be given two numbers. So it makes sense to subtract two numbers, but it doesn't make sense to subtract two strings, right?
Hmm.
So while we can perform quote-unquote arithmetic on strings, what arithmetic means on strings is fundamentally different from arithmetic on numbers, right?
Correct.
Okay. So, okay, let's try something. Can we delete everything again?
Hmm.
I'd like you to write double quotes and then five.
Five in between or five outside
Oh,
the.
five in between. It's a good question. Okay, now let's run it. So no surprises. The same way we wrote hello world and got back hello world, we wrote five in string, we got back five in string. Very nice. Now, can we create a new line? And just write the number five. No strings. All right, now let's run it. No surprises. Got back to number five. Okay, now let me ask you this. Now that we have strings, and strings are a series of characters, and to write a number, you need to write a series of characters. Why do we need numbers? Why not make everything strings?
Exactly. I guess to separate certain aspects.
What do you mean by that?
What I mean is, if we're trying to perform if we're trying to perform a function or something specific, or quotes, uh, use them. If not, leave them.
Can you give a specific example?
Say you want to add the two together. Yeah, two different like functions together, and we want to use the plus function as we just did the first time, and the two words sort of just merge together.
Yep.
Well, yeah. Well, if you're leaving it plain, it's blank is not necessary.
Okay. Here's what I think you're trying to say. Are you saying there's a difference between a string and a number, and the difference is what they do?
Precisely.
Okay. Yeah. So while the same piece of information can be represented with multiple data types, there are strengths and weaknesses to each. So for example, adding two numbers is very different from adding two strings. If we
Hmm.
add five in strings with another five in strings, we'll get five in strings. But if we add the number five and the number five, we get 10, right? Two different operations. And we can't even subtract strings. We can only subtract numbers, right?
Exactly.
So part of our job as programmers is we need to find the most appropriate data type for a given piece of information. I should even say data type, like a data representation. There's a subtle difference which we'll get to in the future. Okay. Um,
Hmm.
we are running out of time, so I'm gonna start wrapping up. You did say that you want to like get to this as a career. Um, so I'll ask you straight, like, do you want homework? Like, do you want me to give you stuff to work on between sessions? It's like completely up to you.
Yeah, I'd love to practice as much as I can. I can create the
Okay.
time, and honestly, I just kind of want a baseline and a timeline really to see how accomplished I can get. Within I don't know 3 month, 4 month, 6 month period. Straight work and consistent work. So anything that'll
Okay.
help get me to my goal, I'm ready for it.
Okay. Okay, so I'm gonna email you two things. First, I'll send you one email which contains two things. The first is I'm gonna send you another student's video because I made a bit more progress on another student, which I think is like 20% more, which will get you, uh, I think at a good level. So if you can, please watch that video to its completion. I think you can just like skip the video until you get to the part that we just stopped.
Okay,
Uh, you'll find that I say the same things to every student. So you'll be like, wait, this guy is like saying the same things. Uh, so that's the first thing. Watch the video. The second thing is I'll send you some exercises to apply what you have learned. Um, yeah. And do you have any like how's the pace that we progress today? Like, do you have any feedback? Is it too fast or too slow?
I think it's just fine. It's the first session, and I we're just getting the ground wet based on my level of expertise right now, which is nil. So uh, I have no complaints necessarily. Definitely not too fast, if anything.
Okay.
So I'm just ready to get my feet wet and dive a little further.
Okay, cool. All right. And I'd like to end my sessions by asking the students, what is one thing that you learned today that stuck with you?
Also, the first thing we did today was just that you can add numbers through functions here, and actually, a more bigger one is you said we encode and recall functions as opposed to how we do it in mathematics. So it's just terminology.
Hmm, cool. Okay. Also, I do want to apologize that I sent the Zoom meeting 2 minutes late. I know we're scheduled for 9, but sent at 9:02. I do apologize for that. I do try to send the meeting links on time. So hopefully, if you do sign up for session in the future, you'll get it on time.
Sounds good. Not a problem.
All right. Okay. I'm very happy to help you on your learning journey in programming, and I hope to see you again.
Absolutely. Have a good one.
All right. Bye-bye.
Bye.